Welcome to another episode of CSC 380, Computer Network Security. Up till now, we have focused on network scanning. We've talked about gaining access to a system through previously known exploits that have been coded into something like the Metasploit framework. We've talked about finding new exploits to gain access to a system using web application vulnerabilities, or even using buffer overflows and regular application vulnerabilities. If we look at that in the context of our attack cycle, what we've done so far is progress from left to right. We talked about reconnaissance, we talked about scanning, we talked about gaining access. But what's next? Now that we have that level of access into our system, what should we be doing next? And those are typically considered to be the post-exploitation activities. They include things like keeping access once you have it, or if you want to be all fancy, establishing persistence. We talk about hiding our tracks so that a system administrator or a security operations team who is paying attention doesn't see that we are there. And if they don't know we're there, they can't kick us off the system. And of course, once we are on the system, we want to use it for something. We either want it because that system has something that we are looking for, or because we want to use the system as a next step in our attack. And that means that we're pivoting our attack off that system. So this week, we'll start looking at these post-exploitation activities. These post-exploitation activities include, a lot of different things. But especially if we start pivoting, we acknowledge the fact that whatever we're looking for, the reason why we were breaking into this system in the first place, cannot be found on that system itself. Instead, we're going to hope and assume that using this system or using this stepstone will get us one step closer to the final target that we're after. And that's called pivoting an attack. Pivoting an attack can take all kinds of different forms, and different methods and techniques are used. And it's really difficult to generalize this into a broad, okay, first you do this, then you do that, and then you're done. You can't really do that. It requires mastery of quite a number of different techniques, and of course also knowing when to apply those techniques. I've listed 5 here on this slide, but this is of course not the only thing that you could possibly be doing once these techniques have been mastered. There could be other things, there will be other things, and we might be talking about some of them down the road in the next couple of weeks. But typical things might be, once we have gained access to a system, let's search that system for things of value. Maybe there are important documents that we might be interested in. Maybe there are stored credentials on the system, someone's username and password that we might reuse on a different system. It might contain passwords or other important things in configuration files. There could be so many different things stored on a system that it's always worth looking around a little bit and try to figure out first what kind of system you're on, and that helps knowing the operating system and where it keeps its different files. But also, if we're looking through the file system, we might be able to find vulnerabilities that have not been patched. Vulnerabilities that maybe weren't apparent as seen from the network, maybe because they are not exposed on the network, but vulnerabilities nonetheless. It could be, for example, a vulnerability in a piece of software that if you exploit it, you could elevate your privileges. Not too long ago, Microsoft Windows had an elevation of privilege vulnerability in it. And that meant that once you had access to a Windows system without having high-level credentials, by running an exploit against that vulnerability, now you ended up with administrator or system level vulnerabilities, privileges. And that is nice because now all of a sudden you can access parts of that system that you were not able to access before. These local elevation of privilege exploits are not unique to Windows. Mac OS has them, Linux systems have them. You need to be able to look for them and figure out what way, shape, or form they are present. And they are not always present, but if they are there, it's good to know and to use them. Elevation of privilege doesn't always need a vulnerability in software. It could just be a software-based, a configuration-based vulnerability. For example, someone could have configured sudo to be allowed for all users on the system without additional verification of passwords. And that would mean that someone who gains access to the system can just type sudo bash, for example, and now you have a prompt that is running with root level privileges. On a Linux system or on a Mac, you just type sudo space dash lowercase l, and that lists out exactly what privileges you have on that system. Now, sudo is something that logs its activities. And that means that the fact that you typed sudo-l or sudo something else is recorded in a system log somewhere. So if you're trying to hide your tracks, that may not be the smartest thing to do. But if you really don't care, or if you assume that the system isn't necessarily managed as well as it should have been, at that point you can easily go ahead and try it. It takes a judgment call. What you can also do is take your new system and start conducting network scans from that system. Because maybe what you're talking to is a system that has more access to the internal network than what you would get scanning from the internet. So repeating a network scan to see what other things you can now reach and get closer to your target is always valuable. And sometimes you might even be able to intercept network traffic, to do a packet capture or a network sniff, as we call them. And that could reveal interesting information as well. All of these are typical post-exploitation activities. Doesn't mean you always need all of them. It does not mean that this is an exhaustive list, but they could be useful methods and techniques. Now, in order to do one of those network packet captures, you have to understand that a system, like we've shown here, the top rounded rectangle, the big one, is the operating system. And the operating system's job, or one of its jobs, is to interact with devices. And in this particular case, we're dealing with a system that has two devices. It has two network interfaces. Sometimes we call that a dual-homed system. And in this particular case, the architecture is such that one interface is meant for the public network, typically the internet, and one interface is meant for the private network. But that means that if you are able to gain access to this system through the public network interface, now the private network traffic might be visible to you as well, or at least some of it. The job of the operating system is to pass that raw data from the interface into the operating system's TCP/IP implementation, its TCP/IP stack. And then based on ports and all kinds of things, the operating system might decide, this is network traffic that is meant for a particular application, and it passes it up. Now, if you're the application and if you're compromising that application, that is the only network traffic that you will be able to see. It's the network traffic that the operating system lets you see. However, if you are able to intercept network traffic using specific tools, what you'll be doing is looking there, right on those interfaces. You'll be looking at the raw network data, the data that is sent to the TCP/IP stack, but before it has been processed by the TCP/IP stack. And that means that at that point, the operating system is unable to hide something from you. And even if you may have access to one network application, network traffic meant for the other, you would not see. Now that you have the ability to do these packet captures, you might be able to see it. You can packet capture on specific interfaces. So I might be able to say I'm not necessarily interested on what's happening on the public network interface, only let me capture what's on the private network interface. Packet capture gives you a whole new tool for your toolkit, and it lets you see that network traffic in a lot of detail. Now, there is a lot of tools out there that can let you do that. The most well-known ones are Tcpdump. Actually, let's start with Tcpdump itself. So Tcpdump is another one of those command line tools that does typically get run with quite a few somewhat obscure command line switches, unless of course you know what those switches mean, and then all of a sudden makes sense. So here I give you an example of Tcpdump. The invocation is basically the name of the program. Now note, before I continue, before you can run this, you probably have to already have administrative level privileges, or you need to be a member of a specially privileged group. So this might not work if you're an unprivileged user on a system, and you may have to elevate privileges first. But assuming we can, so we can run Tcpdump, and then we give it a bunch of parameters. Now these are case sensitive. So the first one is -U. That means that it is unbuffered input. And that's important because what we're trying to do is capture what we intercept and put it right into a file. If we do that according to a buffered capture, it might mean that it's accumulating in memory, but it hasn't been written to the file yet. And if we abort our capture, we might lose some data. So we want it unbuffered and straight written into a file. S0 means let's start saving data right from the 0th byte. In other words, the entire data packet. By default, a tool like Tcpdump will only capture the packet headers, but not the packet content. By adding -S0, you say capture everything, headers and content. -I is short for interface. EN0 is a Linux name for Ethernet 0. So in this case, this is the first internal wired network interface that we're looking to capture on. This saves to a file called capture.pcap, and it doesn't necessarily show something on screen, so it might take a while before you feel that something is happening, but you might be able to see a counter go up, or if you hit a key on the keyboard, it might tell you what the counter is, and showing you how much data it has captured. Once that is done, you have enough. You can just hit Ctrl and C to cancel your intercept, and it will stop capturing. Now you have a file called capture.pcap, which you can read using the same tool. Tcpdump, -R for read, name of the file, capture.pcap, followed by -A. A is for ASCII, so it prints the contents of the network packet as plain text. If you're dealing with a lot of binary data, you might want to replace a -A with a -X. And at that point, it won't print ASCII, it will print hexadecimal values instead. So you can still analyze it that way. Tcpdump is a very lightweight tool. It's also a very popular and widely distributed tool that's available on many different systems. So if you have it and you're able to access the interface, you're able to capture data. Wireshark is a tool that more or less does the same as Tcpdump. It can capture, it can also analyze, but it has a graphical user interface. Because it has a graphical user interface, it is not nearly as lightweight as Tcpdump is. It's also a tool that you need to have console-level interaction with. If you're dealing with a GUI, you need to be able to click on buttons. And if you're on a remote session with just a command line, the GUI doesn't help you much. Wireshark does have a command line equivalent called Tshark. They're part of the same software package, and they have more or less the same functionality, just different syntax. So it's a little tricky to get the syntax right if you're not completely familiar with them. Or if you're used to Tcpdump and you're switching to Tshark, it's frustrating, and the other way around just as much. What does happen quite a bit in practice is that you might see Tcpdump installed on a system, which means that you can then use Tcpdump to create your packet captures and exfiltrate them from that system, just like any other form of data. And after you exfiltrate it, you can download it to your own system and then analyze it there using Wireshark. And Wireshark is fantastic. It has protocol dissectors for just about any protocol you can imagine, and probably a whole lot more than that. It also has a whole lot of advanced functionality, analysis tools, and better than that, it is all free and open source software. It's been ported to just about any operating system you can imagine, so it doesn't matter really what kind of computer you have, you can probably run Wireshark to analyze these packet captures on your computer. The only thing that might be a little tricky is if you're running on a Chromebook. I don't know if it's possible then, or an iPad. But in these packet captures could be a lot of good information. For example, even though we really should not see them at all anymore, many enterprises still run a lot of legacy protocols on their internal network. You might see things like HTTP, not HTTPS, just HTTP. FTP, the file transfer protocol. POP, the post office protocol. That's a protocol you use to download emails from a server. It's very easy to automate against that, so that's why you often still see it. IMAP is the Internet Mail Access Protocol that's used to manipulate email on a remote server without necessarily downloading it. Telnet is like SSH, but then much earlier. It's a much easier implementation than SSH, so sometimes you'll see it on lightweight devices or on cheap devices. Now, the disadvantage of those protocols is not that they don't work. They work very well, but they transmit their credentials and everything else in plain text. And that means if you can intercept that network traffic, you can intercept the credentials or the payload, whatever it is that they are transmitting over the wire. And at that point, you don't have to break into a remote system. You can just wait for that information to be exchanged with the remote system and capture it that way. Now, unfortunately, today, or maybe not unfortunately, maybe fortunately, but today almost all network traffic is encrypted using TLS. So if you know the old name SSL, you really shouldn't be using SSL anymore. It's deprecated. It's called TLS now. Transport Layer Security. TLS is a wrapper. It's not an application by itself. It's an extra layer that you can stack on top of a network protocol. And that network protocol layer, the TLS layer, then provides encryption services. But, as one of the main design goals for using that level of encryption is that if someone intercepts encrypted network traffic, it doesn't make sense what it represents to the interceptor. I can look at a packet capture and maybe still recognize a source port and a destination port, but if it's encrypted, I don't know what's being transmitted inside that network stream. TLS provides that. It also provides integrity, which means I can't manipulate that stream anymore. It provides authentication. At least one side of a TLS conversation authenticates to the other side. And if you want to, you can have both sides authenticate to each other. And that means that there's a lot of protection that you're getting from the use of TLS without necessarily having to change how your program works. And as a result, implementing TLS is not that difficult. On top of that, almost all search engines and web browser manufacturers are really pushing very hard for the use of TLS. So all web-based applications should be HTTPS only at this point. And that means that the effectiveness of network packet capture is diminished. If something is encrypted well, you cannot decrypt it by just looking at the ciphertext, the encrypted content. However, there are situations in which, for example, a developer or a system administrator who's troubleshooting something might turn on a feature in a browser that makes the browser record the encryption keys for each transfer. Those are called SSL or TLS session keys. If you have those, if you have the TLS session keys, at that point, you are able to decrypt network traffic. Wireshark can do this and Tshark can do this. I do not think that TCP dump by itself can do this. But so, if you have a packet capture, and if you have the session keys, by configuring Wireshark or Tshark to read those session keys from the file and applying them to the HTTPS stream, you can decrypt that stream as if it were a plain text stream. And at that point, stuff is all completely legible. The next two videos talk about this. They talk about post-exploitation activity. They give you a little bit more background about the use of cryptography. And we talk about some common mistakes and common errors that can be leveraged in a post-exploitation scenario. So watch this video, well, you just did, and watch the next two, and we're all caught up for this week. That's it for now.